Existing anti-flu drugs like Tamiflu and Influenza are said to work inside the virus cell to prevent reproduction inside the human body. But new research by my guest, UC San Diego scientist Miriam Cohen, suggests there may be a better way to treat the flu. Welcome.
Hi, it's nice to be here.
So, Dr. Cohen, in layman's terms, how does the current flu vaccine work?
So the vaccine works basically by introducing our immune cells with a picture of the enemy. So in case that you get exposed to the flu, your immune cells knows right away to attack it and destroy it before you get sick.
Attack this foreign cell. Well, how would the therapy be, which hasn't been invented yet, based on your therapy, how would that be different from that process?
So what we were looking into is our natural mucus, or our natural body, defends us against the flu. So our airways are covered with mucus layer that present decoy molecules, sugar molecules for the flu virus to bind to. And we want to see how we can enhance that in order to prevent us from getting sick.
So basically, you're looking at a physical barrier, mucus as a physical barrier to stop the virus, but it doesn't happen that way right now, right?
So basically, you can think about the mucus as a spider web like of sugars. So when the virus tries to get through it, it gets stuck on these sugars and is unable to reach it to the cells.
We're looking at that human goblet cell. That's a fat cell, right? And the blue in there we're seeing, that's the mucus and the sugars?
So a goblet cells is a mucus producing cells, and mucus are proteins that are covered with sugars, and the goblet cell secretes a large layer of mucus that covers our airways, and that's what the virus gets stuck in.
So it can sort of like a trap. It can like quicksand or something.
Yes.
I want to show folks a picture of the flu virus cell. It's actually pretty nice looking. It looks pretty nice, but it's not nice inside your body. Walk us through how, if you have this flu virus that we're looking at right now, influenza virus inside your body, how would entrapping it in the mucous membrane, walk us through the research. How do those two link up?
So as you can see, these little spikes on this virus membrane or virus surface, these represent two interesting proteins. One that binds to that sugar I was mentioning before, and the other one that cleaves that sugar, cuts it like scissors. So there you have spider web of sugars, the mucus layer, that the virus get stuck on it by holding on to these sugars. However, at the same time, the virus brings out these scissors and clips himself free. So it's basically a matter of timing. Can the virus cut himself free fast enough to before the mucus get cleared in order to infect the cells or not?
So now you're at the early stages of identifying this as far as in your research goes, but as your research progresses, how would that turn into a treatment?
So basically, currently the Tamiflu and Influenza drug that you have mentioned before, what they do is they really jam these scissors. They prevent the virus from cutting itself free.
And spreading. It would cut itself free and float or migrate into other cells.
And to other cells and get you more sick. However, people have overlooked the fact that it also helps the virus to get stuck in the mucus, and therefore it doesn't allow you to infect in the first place. However, they are very strong drugs. We can make less potent drugs that would be as efficient and as effective in preventing the virus from going through the mucus layer.
By trapping them in the mucus layers.
Yes, because you don't need to completely cripple the virus. You just need to slow it down enough to stay in the mucus until we get the mucus washed off.
I see. I see. And so that could develop into new therapies, potentially new drugs. And so how would you go about that? What would the next steps be?
So these kind of treatments would be catered toward if you suspect that you're in an environment where people are sick, or if you're going to travel in an airplane or something and you want to make sure that you're going to get there without catching the flu, then you would be able to take that medication that would enhance your own immune protection, or the capability of your mucus layer to protect against the infection. It will not be replacing vaccination. Vaccination actually protects you throughout the flu season. It would just be
to prevent it from actually getting, and
yes.
This would be after the fact, after you got it. So
it would be when you know that you might be exposed. Say everyone in your office is coughing, you want to make sure you don't get sick.
Okay. Okay. Well, I know we have a few years to catch up to you on that and follow through with it. So research scientist Miriam Cohen, thank you very much for the update.
Thank you so much for having me here.